What is a polynomial?
In its simplest form, a polynomial is a mathematical equation that involves a sum of powers in one or more variable, all of which is multiplied by coefficients. In such equations, variables and numbers on both sides of the equal sign are considered polynomials. For example, by expanding out the expression, x2, 3, or multiplying out the equation, we discover that x2, 3 equals x3 6x2 plus 12x8, which is a polynomial equation.
What are some types of mathematical models?
Mathematical models are commonly broken down into numerical or analytical models. Numerical models are those that use some type of numerical timing procedures to figure out a model's behavior over time. The solution is usually represented by a table or graph. An analytical model usually has a closed solution. In other words, the solution to the equations used to describe changes in the system can be expressed as a mathematical analytic function. Mathematical models can also be divided in other ways. For example, some models are considered deterministic, or a model that always performs the same way for a given set of initial conditions, or stochastic, or a model in which randomness is present.
What are some examples of algebraic equation solutions?
The following lists some simple solutions to selected algebraic equations. To solve for the equation 4x4 equals 12, add 4 to each side, 4x equals 16, then divide both sides by 4, x equals 16/4, then solve for x equals 4. To solve for the equation, x plus 3, 2, 4x equals x1, 2 plus 3. Expand each side by first doing the operations within the parentheses, x2 plus 2x plus 9 equals x2 2x plus 4, then add x2 to each side. Another way of subtracting 2x plus 9 equals dash 2x plus 4, then add 2x to each side. 4x plus 9 equals 4, then add minus 9 to each side, 4x equals minus 5, then multiply each side by January 4th, divide by 4x equals minus 5/4.
What is the geologic time scale?
The geologic time scale is a way of managing large amounts of time in a convenient chart. The scale is actually a measurement encompassing the entire history of the Earth from its beginnings some 4.55 billion years ago to the present day. The largest divisions include eons, eras, and periods. The smaller time divisions include epochs, ages, and subages.
What is physics?
Physics is often described as the science of the interactions between matter and energy. It includes the subfields of atomic structure, heat, electricity, magnetism, optics, and many other phenomena. Traditionally speaking, physics is divided into classical and modern, although many subdivisions of the two overlap and both are ruled by mathematics. Classical physics includes Newtonian mechanics, thermodynamics, acoustics, optics, electricity, and magnetism. Modern physics includes such fields as quantum field theory and relativistic mechanics. Other common divisions of physics are experimental and theoretical physics. Theoretical physicists use mathematics to describe the physical world and predict how it will behave. They depend on experimental results to check, understand, change, or eliminate theories. Experimental physicists test their predictions with practical experiments, often using mathematics to conduct the experiments.
What is numerology?
Numerology is the study of the supposed influence numbers have on human affairs. It is considered an occult art in which numbers are used to reflect the spiritual characteristics of people. In general, numerologists match numbers, such as birth dates, to letters, such as names. Then predict things such as a person's purpose in life, their areas of talent, and even behavior patterns. Numerology charts use the numbers 1 through 9, 11, and 22. The values from birthdays and names are divided so that they equal one of these numbers, with each number indicative of something about the person, such as the life path number, expression number, and so on. Although many people use numerology to make life plans or decisions in their life, and some people claim it does work for them, there is no mathematical or scientific basis for numerology claims.
How are the shapes of crystals classified?
Geometry plays an important part in the study of minerals. This is because certain minerals exhibit specific shapes called crystals, with specific crystalline forms occurring when a mineral's atoms join in a particular pattern or internal structure. This arrangement is determined by several factors, including the chemistry and structure of the mineral's atoms, or even the environment in which the crystal grew. Overall, there are specific angles between corresponding faces of all crystals. Mineralogists, scientists who study minerals, divide these crystalline forms into 32 geometric classes of symmetry. They use this information to identify and classify certain minerals. The crystals are also subdivided into 7 systems on the basis of an imaginary straight line that passes through a crystal's center, or axis. The 7 groups include cubic, or isometric, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and trigonal, or rhombohedral. For example, a crystal in the cubic system has 3 axes that intersect at right angles. The axes are also of equal lengths. The best way to envision this crystal is to think of a box with equal sides or a cube.
What was the driving force behind the development of accurate clocks?
The true driving force behind accurate clocks began around the 16th century in relation to finding longitudinal measurement. As countries began to explore the world, an accurate way of telling a ship's position became a critical problem. With one time standard around the world, and clocks to tell those times, longitude, and thus position, could be determined. This would not only mean an increase in exploration but also wealth for the sponsoring country.
Who first introduced Arabic notation and the concept of zero to Europe?
Italian mathematician Leonardo of Pisa, c. 1170 1250, who was also known as Fibonacci, or son of Bonaccii, although some historians say there is no evidence that he or his contemporaries ever used that name, brought the idea of Arabic notation and the concept of zero to Europe. His book Liber Abaci, the Book of the Abacus, not only introduced zero but also the arithmetic and algebra he had learned in Arab countries. Another book, Liber Quadratorum, the Book of the Square, was the first major European advance in number theory in 1,000 years. He is also responsible for presenting the Fibonacci sequence. For more information about Fibonacci and the Fibonacci sequence, see Math Basics.
What is operations research?
Operations research, more commonly called optimization theory, is a form of applied mathematics designed to determine the most efficient way of doing something by using mathematical models, statistics, and algorithms in the decision-making process. It is a branch of mathematics that entails the many diverse areas of optimization and minimization, including the calculus of variations, control theory, decision theory, game theory, linear programming, and many others. Operations research is most often used to analyze complex, real-world systems, stressing the improvement in or optimization of performance.
What is geology?
The word geology comes from the Greek geo, meaning the earth, and the ology suffix comes from logos, meaning discussion. Overall, geology is considered to be the study of the earth. In modern times, thanks to space probes reaching into the solar system. Geology also now entails the surface features on other planets and satellites.
What are interpolation and extrapolation?
Interpolation in mathematics involves finding a value, or outcome, of a function between already known values. In other words, it is a method of estimating the values in between sampled data points. Extrapolation in mathematics is estimating the value of a problem beyond the range covered by the existing data. Both methods are used a great deal in engineering.
What is sea level?
Sea level is the height of the ocean's surface at a certain spot and depends on changing conditions. It is also the basis for most Earth surface measurements. Because sea levels are used as a reference point in determining land elevations and ocean depths, scientists have averaged out the highest and lowest altitudes and depths from sea level locations. The highest is Mount Everest, Nepal, Tibet, which measures 29,022 feet, 7 inches, 8,846 meters, above sea level. The lowest on land is the Dead Sea, Israel, Jordan, which measures 1,299 feet, 396 meters, below sea level. The greatest depth below sea level is the Mariana Trench in the Pacific Ocean. A deep chasm measuring 36,201 feet, 11,033 meters, below sea level.
What is GIMPS?
GIMP stands for the Great Internet Mersenne Prime Search. A program started in January 1996 to discover new world record-sized Mersenne prime numbers. It harnesses the power of the Internet and thousands of small computers belonging to public and private concerns to make the necessary calculations. GIMPS uses only about 8 megabytes of memory and about 10 megabytes of disk space. Per computer, a small amount of space for such a large undertaking. A Pentium-class computer is necessary, and the computer should be on most of the time. But if you decide to join the GIMPS group, be patient. A single test can take about a month to complete. To find out more, get on your computer, log on to the Internet, and access the address http://www.mersenne.org/prime.htm.
What are the probability and odds of drawing a certain card from a deck?
The probability of an event is usually described as the chances for the event to occur over the total chances for the event to occur, chances for/total chances. In the case of a deck of 52 cards, the probability of drawing a king from the deck is 450 seconds equals 1/13 equals 0.077, or 7.7%. As seen above, the odds, or the ratio of chances for to chances against, chances for, chances against, can be found by the formula, total chances equals the chances for plus chances against. Or total chances equals chances for plus chances against, or chances against equals total chances for. Thus, the odds of picking a king from a deck of 52 cards is 452 4, equals 448 equals 112.
How did Albert Einstein use mathematics?
German-born American theoretical physicist Albert Einstein. 1879 to 1955, is recognized as one of the greatest physicists of all time, but he was also a notable mathematician. In 1905 he developed the special theory of relativity, mathematically demonstrating that two observers moving at great speeds with respect to one another will experience different time intervals and measure lengths differently. That the speed of light is the speed limit for all objects having mass, and that mass and energy are equivalent. By around 1915, Einstein completed a mathematical formulation of a general theory of relativity, this time adding gravitational effects to determine curvature of a time-space continuum. He further tried to discover a unified field theory, which would combine gravity, electromagnetism, and subatomic phenomena under one set of rules, but he, and no one since, has ever found such a theory. For more about Albert Einstein, see History of Math.
In what ways does mathematics apply to music?
There are many ways in which mathematics applies to music, from harmonics to the concept of octaves and scales. There is a most interesting connection in that both music and mathematics are experienced as pure objects of the brain, and both have meaning outside of the brain only through artificial connections. For example, there is a mathematical reason why certain note combinations sound harmonious to most people. One good example is a violin string. When it is plucked, the string vibrates back and forth, creating mechanical energy that travels through the air as wave patterns. The number of times the waves reach a person's ear is called the frequency, which is measured in hertz, or cycles per second. If more waves are heard within a certain time period, the note's pitch sounds higher. Chords sound harmonious to us because of waves and ratios. For example, take the C major chord, in which the note middle C is 261.6 Hz. The note E is 329.6 Hz, and the note G is 392.0 Hz. The ratio of E to C is about 5/4, or every fifth frequency wave of E matches with every fourth wave of C. The ratio of G to E is also about 5/4, and the ratio of G to C is about 3/2. Because the notes' frequencies match with the other notes' frequencies, they all sound harmonious to a person's ear. It is interesting to note that none of the ratios for the familiar Western-style scale are truly exact, but rather are approximations. This is because when this scale was put together, the creators wanted to make the notes go up in equal intervals and the ratios to be in tune. The only way to do this was to compromise and use inexact ratios.
What is an indeterminate number?
As with many other fields, mathematics has terms that are sometimes confusing or overlapping. For example, it is interesting to note that there is such a number as 0/0, which is called an indeterminate number. But be careful, this is not the same as an undefined number. If an indeterminate number comes up somewhere, you never know the value for your specific case and you can conceivably give it any number of values.
What is the perimeter of a two-dimensional geometric figure?
The perimeter of a two-dimensional figure is what we perceive as the outside of the object. Mathematicians describe a perimeter more precisely as the sum of the lengths of a polygon's sides. The perimeter of a simple closed curve is measured as its length.
What do cholesterol numbers mean?
Cholesterol numbers indicate the amount of cholesterol in the bloodstream. Cholesterol is a waxy, fat-like substance manufactured in the liver and found in all tissues. For humans, a total cholesterol number above 200 means there is an increase in the risk of heart disease. Between 200 and 239 is considered borderline high cholesterol. For anything below 200, there is less of a risk for heart disease. But total cholesterol is not the only number to know. There is also low-density lipoprotein, LDL, or bad cholesterol. LDL is the main source of the buildup and blockage in the arteries. Risk levels are above 130, measured in milligrams per deciliter. There is also high-density lipoprotein, HDL, the good cholesterol that helps keep the plaque from building up. Risk levels are below 40, measured in milligrams per deciliter. When there is too much cholesterol in the blood, it can build up on the walls of the arteries. Over time, the buildup, often called plaque, causes hardening of the arteries, or a narrowing of the arteries that restricts or stops blood flow to the heart.
How is the product of two vectors determined?
There are two distinct types of products of two vectors, scalar and vector products. Sometimes called the inner and outer products, mostly in reference to tensor products, see below. The scalar, or dot, product of two vectors is not a vector, because the product has a magnitude but not a direction. For example, if A and B are vectors, of magnitude A and B, respectively, their scalar product is, AB equals ab cos 8, in which 8 is the angle between the two vectors. This scalar quantity is also called the dot product of the vectors. These equations obey the commutative and distributive laws of algebra. For more information, see algebra. Thus, AB equals BA, A, B plus C, equals AB plus AC. If A is perpendicular to B, then AB equals 0. The vector, or cross or skew, product of A and B is the length C equals ab sin 8, its direction is perpendicular to the plane determined by A and B. In this case, this kind of multiplication does not follow the commutative law, as AB equals BA.
What are examples of polynomials with one root and no roots?
The following is an example of a polynomial with only one root, x2 plus 6x plus 9 equals 0, x2 plus 6x plus 6 halves, 2, 6 halves, 2 plus 9 equals 0, x plus 3, 2 9 plus 9 equals 0, x plus 3, 2 equals 0, x plus 3 equals 0, x equals minus 3. Or the polynomial has only one root, x equals minus 3, but not all polynomials have roots. The following is an example of a polynomial with no root, 2x2 6x plus 8 equals 0, 1/2, 2x2 6x plus 8, equals 1/2, 0x2 3x plus 4 equals 0, x2 3x plus, minus 3 halves, 2, minus 3 halves, 2 plus 4 equals 0, x 3 halves, 2 9/4 plus 4 equals 0, x 3 halves, 2 plus 7/4 equals 0, x 3 halves, 2 equals minus 7/4 because a real number squared is greater than or equal to 0, that means, x 3 halves, 2 will always be greater than or equal to 0. Thus, the answer can't be minus 7/4, a negative number, and there are no real roots for this polynomial.
What are some examples of mathematical models used by chemical engineers?
There are numerous examples of how mathematical models are used by chemical engineers, too many to mention them all here. One good example is modeling crystal growth. Liquids from water to molten metals become crystalline solids as they are cooled. Engineers can mathematically design software that helps in the manufacture of superior crystalline growth, especially for electronics and other industries. These improved crystal forms advance the quality of electronic hardware, including computers, and help engineers design better alloys for a wide range of applications.
How else is the term function used?
Unfortunately, as with many mathematical terms, there is often more than one function for the word function. For example, contrary to the definition above, function can also mean the relationships that map single points in the domain to multiple points in the range called multivalued functions, which is mainly used in the theory of complex functions. To further confuse matters, there are also functions called non-multivalued functions.
What is a decimal system?
The decimal system uses the base 10 notation system to represent real numbers. A decimal expansion is the expression of a number within the decimal system, such as 1, 15, 359, 18.7, and 3.14159. Each number within the system is called a decimal digit. Such decimal notation, or a numbering notation based on decimals, was first used in India around the year 594. The decimal point is represented by a period placed to the right of a unit's place in a decimal number. It is interesting to note that a comma is used in continental Europe to denote a decimal point, such as 3,25, translated as 3.25, which in this case would logically be called the decimal comma.
How old is the study of fluid mechanics?
According to many historians, fluid mechanics may be the oldest subfield in physics and engineering. In particular, ancient civilizations needed to control water flow for agricultural development, drinking water supplies, and transportation. Thus, the development of fluid mechanics, which is the study of the motion and behavior of fluids, led to even more, and complex, improvements. For example, agricultural requirements led to irrigation waterways, dams, weirs, pumps, and even crude forms of sprinkler systems. The need for a potable, drinkable, water supply led to better wells, fountains, and water storage systems, and water transportation innovations included improved sails and rigs, as well as methods to build and waterproof sailing vessels. But early fluid mechanical studies did not end there. Over time, they extended into almost every realm of science and engineering. For example, mechanical engineering uses fluid mechanics because of the need to know about fluids used in combustion. Ships and automobiles, lubrication, from the smaller inner workings of a wheel to larger mechanisms such as locks along a canal, and energy systems, hydroelectric power. Civil engineering utilizes fluid mechanical studies to interpret how fluid systems traveled over structures. Aqueducts and pipes carrying drinking or waste water. Electrical engineers use fluid flow to analyze how to cool electronic devices with either air or water. Even early, and current, aeronautical engineers needed to know how air flowed over an airplane wing. providing the much-needed lift that allows a plane to become airborne.
What is the order of operations when one simplifies an algebraic equation?
Here is a certain order to working out an algebraic equation. The following lists the operations in their correct order. Do what is inside the parentheses. Do the exponents. Do all the multiplications and divisions from left to right. Do all the additions and subtractions from left to right. There are also rules when it comes to grouping in algebraic equations, especially when working with parentheses. When an expression has parentheses within parentheses, work from the inside out. Removing the innermost parentheses first. And remember, if there is a positive sign in front of the parentheses, it does not change any sign inside the parentheses. If there is a negative sign in front of the parentheses, it will change all the signs within the parentheses.
Why are some prefix names different in measurements?
The main reason why a prefix name would differ has to do with pronunciation and vowels. If the first letter of the unit name is a vowel and the pronunciation is difficult, the last letter of the prefix is omitted. For example, a metric measurement of 100 ares, 2.471 acres, is a hectare, not hectare, and 1 million ohms is a megohm, not megaohm. There are exceptions, though, especially if the resulting prefix and unit sound fine, such as a milliampere. There are even times that another letter is added to make it easier to roll off the tongue. For example, the letter L is added to the term for 1 million ergs, making it a megalerg, not a megaerg or megerg.
What is the difference between the various pounds and ounces?
The story behind the ounce is long and convoluted because historically people have been dissatisfied with the unit. For example, in medieval times English merchants were not happy with the troy pound, as it was less than the commercial pound in most of Europe. In response, the merchants developed an even larger pound, which was called the libra mercatoria, or mercantile pound. But by 1300 the complaints about the mercantile pound grew, because 15 troy ounces, or 7,200 grains, were easily divided by 15 and its divisors, but this was not as convenient as dividing by 12 troy ounces. Soon, another type of pound was born in English commerce, the 16-ounce avoirdupois. Roughly translated from the Old French as goods of weight. Modeled on a common Italian pound unit of the late 13th century. The avoirdupois pound weighed exactly 7,000 grains, which is easily divided for use in sales and trade. But because it was difficult to convert between the troy and avoirdupois units, The avoirdupois ounce is 7,000/16 or 437.5 grains, and 1 grain equals 1/7,000 avoirdupois pound. Or 1/5,760 troy or apothecaries pound. The troy ounce is 5,760/12,480 grains. Or 31.1035 grams in metric. The standard soon shifted to using mostly the avoirdupois unit. The avoirdupois is currently used in the United States and Britain. It is equal to 1/16 of a pound, or 28.3495 grams, in metric. The avoirdupois ounce is further divided into 16 drams, or dram. The troy ounce hasn't been totally forgotten, though. Today, it is used mainly as units for precious metals and drugs, where it is often called the apothecary's ounce. With its subdivisions of the scruple, or 20 grains, and the dram, or 60 grains. In turn, the avoirdupois hour ounce for short is used for almost everything else.
What are the basic set operations?
There are several basic set operations, the most common being the intersection of sets, union of sets, and the complement of sets. The following lists these operations. Note, the first two operations obey the associative and commutative laws, and together they obey the distributive law. Intersection. The intersection of two sets is the set of elements common to the two sets. For example, the intersection of sets A and B is the set of elements common to both A and B. This is usually written as A and B. Thus, if A equals 1, 2, 3, 4, and B equals 3, 4, 5, then the intersection of A and B would be 3, 4. Union. The union of sets is the combining of members of the sets. For example, the union of two sets A and B is the set obtained by combining members of sets A and B. This is usually written as AUB. Thus, if A equals 1, 2, 3, 4, and B equals 3, 4, 5, then the union of A and B would be 1, 2, 3, 4, 5. Complement or complementation. When the set of all elements under consideration must be specified, it is called the universal set. And if the universal set is U equals 1, 2, 3, 4, 5, and A equals 1, 2, 3, then the complement of A, or A, is the set of all elements in the universal set that are not A, or 4, 5. The intersection between a set and its complement is the empty or null set. 0. The union of a set and its complement is the universal set.
What is supply and demand?
In economics, there are certain factors that control the availability of and the demand for a product. In particular, supply refers to the varying amounts of a good producer's supply at different prices. Simply put, a higher price yields a greater supply. Demand refers to the quantity of a good demanded by consumers at any given price. In general, the law of demand states that demand decreases as the price rises. In an ideal world, the supply and demand would be balanced. Thus, the law of supply and demand predicts that the price level will move toward the point that equalizes the quantities that are supplied and demanded. Economists use charts and graphs to indicate price and quantity, showing the lines of demand and supply, along with where there would be shortages and surpluses. Where the supply and demand curves meet, balance is established. There are also charts that show a shift in demand or supply, resulting in a new supply-demand balance point.
What are some non-Hindu Arabic numerals encountered around the world?
Although Hindu Arabic numerals are the dominant numerals used around the world, there are some places in which other number symbols are used. For example, there are Chinese, Japanese, Kanji, Greek, Thai, and Hebrew numerals. The illustration lists some of the ones encountered by world travelers. For more information about numbers, see Math Basics.
What are geometric transformations?
Geometric transformations are rules that mean there is a one-to-one correspondence between two sets of points in two figures. A geometric transformation changes the plane or three-dimensional space. Each transformation can be defined by thinking about where each point is taken, with the point said to be taken to its image. One way to visualize a transformation is to think of expanding, shrinking, or moving one figure to get a second figure. Depending on the transformation, the image will either be congruent, equal, to the original image, called the identity transformation, similar but not necessarily equal, or will not resemble the original at all.
What is an array?
A mathematical array is a list of lists, or a rectangular arrangement of objects. It is a useful way of keeping a collection of things. Arrays are orderly arrangements of objects in columns and rows, with the objects most often being numbers. For example, the most common arrays are two-dimensional with a certain amount of rows and columns. In this case, this is a 2 by 3 array, rows are always mentioned before columns. The order of numbers and slash or elements in an array may sometimes, but not always, be significant, as it is in a matrix, see below.
What is density?
Density, usually abbreviated as D or R, is a mathematical concept used to describe the ratio between the mass of an object and its volume. The actual formula is the density times the volume is equal to an object's mass, or dxv equals m. In the standard, American, measurement system, density is measured in pounds per cubic foot. But in the sciences, the metric system is usually used and density is measured in grams per cubic centimeter, or grams per milliliter. For example, the density of water is 1 gram per cubic centimeter. Lead is 11.3 grams per cubic centimeter, and gold is 19.32 grams per cubic centimeter. Note, in the majority of cases, the higher the density, the heavier it feels to us on Earth.
What were some early measurements of weight?
Some of the early measurements of weight include the grain, pound, and ton. Ancient peoples used stones, seeds, and beans to measure weight. But grain, such as wheat or barley corn, was a favorite. In fact, the grain, abbreviated GR, is still one of the smallest units of weight used today. To compare, 1 pound equals 7,000 grains. The traditional pound as a unit of weight was used throughout the Roman Empire. But like many other measurements over time, the number of ounces in a pound seemed to shift and change. For example, the number of ounces in the Roman pound was 12. European merchants used 16 ounces to the pound. Eventually, 16 ounces in a pound became standard. For more about ounces, see below. Back in the 19th century, the Americans who did not like the British larger weights decided that a hundredweight would equal 100 pounds, the British hundredweight was 112. This meant a ton was equal to 20 hundredweight for the American ton, or the Americans' short ton was 2,000 pounds. While the British long ton of 20 hundredweight was equal to 2,240 pounds. There were, of course, debates, but not everyone disagreed with the American short ton. It became the favorite of British merchants, who called it a centile. Eventually, the ton on the international market went metric. And today a metric ton is close to the original British long ton. It is equal to 1,000 kilograms, or approximately 2,204 pounds, and is officially called a ton. Although the international system, SI, CP 50, standard uses ton, the United States government recommends using the metric ton.
What is a truth table?
A truth table is a two-dimensional array of truth values derived by determining the validity of arguments through assigning all possible combinations of truth values to the statements. This simple form of logic depends on a combination of certain statements. Using terms such as not or and, along with the input values. The first columns correspond to the possible input values and the last columns to the operations being performed. The rows list all possible combinations of true, t, or false, f, inputs, together with the corresponding outputs.
How is mathematics used to determine resistor values in an electrical network?
Electrical engineers who deal with systems and circuit theory need to know the terms and functions of the basic circuit element resistor, capacitor, and inductor in terms of current voltage associations determined by impedance, obstruction. Complex numbers, calculus, and Laplace transforms, see above, are all mathematical concepts used to understand circuit theory. The best way to understand the basics are through the following simple equations. Resistor voltage equals current, I, times resistance, R, or V equals IR. Capacitor voltage equals the square root of -1, J, often called I, or an imaginary number, times frequency. W, times the capacitance, C, all times the current, I, or V equals, JWC, I. Inductor voltage equals the current divided by the square root of -1, J, times frequency, W, times inductance, L, or V equals I/JWL.
What is a null or empty set?
A null or empty set contains no elements. An empty set is considered to be a subset of every other set. The opposite of an empty set is, logically, a non-empty set, or one that is not empty. The notations for empty set are and 0, but not, as it is sometimes written in texts. Interestingly enough, an empty set is considered to be both open and closed for any set X.
How is a dimension described in mathematics?
In mathematics, a dimension is the number of coordinates, or parameters, required to describe points of or even points on a mathematical object, usually geometric in nature. The dimension of an object is often referred to as its dimensionality. For more about coordinates, see elsewhere in this chapter. For more about dimensions and science, see Math in the Natural Sciences. Each dimension represents points in space from a single to multiple points. The concept of dimension is important in mathematics, as it defines a geometric object conceptually and/or visually. In fact, the idea of dimensions can even be applied to abstract objects that can't be directly visualized. Mathematicians most often display such dimensions on graphs using a single point. For example, x, to represent one dimension, 2 points, usually x and y, or an ordered pair. To represent 2 dimensions, and 3 points, usually x, y, z, for 3 dimensions. the 4, and higher, dimensional analogues of three-dimensional objects. Often retain the prefix hyper dash such as hypercube and hyperplane. The basic geometric structures of higher dimensional geometry: the line, plane, space, and hyperspace all consist of an infinite number of points arranged in specific ways.
What is the set theory approach to arithmetic?
The set theory approach to arithmetic is defined in terms of the non-negative whole numbers 0, 1, 2, 3. These numbers are identified with specific sets based on the placement and number of brackets. For example, mathematicians identify 0 with the empty set, 1 is identified with, 2 is identified with, 3 is identified with, and so on. Each bracket is an interpretation of the empty set and 1, or.
What are astronomical units in light years?
An astronomical unit is one of the more common measurements used in astronomy. It is a distance equal to the average distance from the Earth to the Sun, or 92,960,116 Halley's Comet, named after Edmund Halley. Last appeared near Earth in 1986 and will be seen again in the night sky in 2062. Stone/Getty Images. Miles, 149,597,870 kilometers. It is often seen rounded off to 93 million miles. 149,598,770 kilometers, and used in reference to great astronomical distances. For example, the Earth is 10 from the Sun, the planet Venus is 0.70. Mars 1.50, Saturn 9.50, and the farthest planet, Pluto, is 39.50 from the Sun. A light year is an even larger unit. As the name implies, it is the distance light travels in 1 year, or about 5.88 trillion miles, 9.46 trillion kilometers. In most cases, light year measurement is reserved for deep space objects. For more about measurement, see mathematics throughout history.
What is a mathematical space?
Outer space may be the final frontier to some people. But back on Earth there are also numerous types of space in mathematics. For the most part, mathematical space consists of points, sets, or vectors. Each space and the members of that space obey certain mathematical properties. Most spaces are named after their principal investigator, including Euclidean and Minkowski space. One of the most general types of mathematical spaces is called the topological space.
How is wind measured?
Wind speed is the measurable motion of air with respect to the surface of the earth. It is measured in terms of a unit distance over a unit time, such as miles per hour. The wind direction is also an indication of the wind's source. For example, a southerly wind means the wind is blowing toward north. It is coming from a southerly direction.
What is a normal distribution?
A normal distribution is an idealized view of the world, producing the familiar, symmetrically shaped bell-shaped curve. It is usually based on a large set of measurements of one quantity such as weights, test scores, or height, which are arranged by size. In a normal distribution, more than 2/3 of the measurements fall in the central region of the graph. About 1/6 of them are found on either side. Many of us are familiar with the normal distribution from standardized school test scores, as most result in a bell-shaped curve, with students hoping to at least fall in the middle of the curve.
What are the surface area, lateral area, and volume of a sphere?
A sphere is a set of points equidistant from a central point. A center, a sphere in 2 dimensions, is a circle.
What early mathematicians are thought to be responsible for originating the use of algebraic methods and ideas?
To some scholars, Greek, Hellenic, mathematician Diophantus, c. 210 c. 290, is considered the father of algebra, as he developed his own algebraic notation. His words were noted and preserved by the Arabs. The translation of his words into Latin in the 16th century led to many algebraic advances. In more modern times, French mathematician François Vide, 1540 to 1603, also known by the Latin name Franciscus Vitae, is often credited as the founder of modern algebra. For more information about Diophantus and Vitae, see below and History of Mathematics.
What is the Titius-Bode law?
The Titius-Bode law was developed by German astronomer Johann Daniel Titius, 1729 to 1796. Titius's idea was brought to the forefront by German astronomer Johann Elert Bode, 1747 to 1826. The law actually represents a simple mathematical rule that allows one to determine the distances, also called the semi-major axis, of the planets in astronomical units. It is determined using the equation A equals 0.4 plus 0.3, 2n, in which n is an integer and a is the astronomical unit. Interestingly enough, most of the planets and even the asteroids in the asteroid belt adhere to the law. The only exception is Neptune, the second to last planet in our solar system.
What were the two fundamental ideas in the development of numerical symbols?
There were two basic principles in the development of numerical symbols. First, a certain standard sign for the unit is repeated over and over, with each sign representing the number of units. For example, 3 is considered 3 in Roman numerals. See the Greek and Roman mathematics section below for an explanation of Roman numerals. In the other principle, each number has its own distinct symbol. For example, 7 is the symbol that represents 7 units in the standard Hindu-Arabic numerals. See below for an explanation of Hindu-Arabic numbers. For more information, see Math Basics.
What is an undefined term?
In terms of axiomatic systems, undefined terms are also called primitives. Although it sounds like doublespeak, these primitives are object names. But the objects they name are left undefined. The axioms are statements within the system that make assertions about the primitives. If a meaning is attached to a primitive, it is called an interpretation. Undefined terms are also found in a mix of axiomatic systems and geometry in which definitions are formed using known words or terms to describe a new word. There are 3 words in geometry that are not formally defined: point, line, and plane, because they can't be described without using words that are themselves undefined. These terms are fundamentally important in the study of geometry, because they are needed to further describe even more complex objects such as circles and triangles. For more about geometry, see geometry and trigonometry.
What are some of the statistical data gathered during the periodic United States Census?
Every 10 years, the U.S. government takes a census that gathers important statistical data about the entire population. In the 2000 census, this included place of residence, age, gender, race, ancestry, marital status, education, date of birth, place of birth, disabilities, work information, military service, language spoken at home, housing information, and school enrollment. Not all questions are repeated each census year. For example, 100% of the population was asked about their marital status in 1990, in 2000. It was only asked on a sample basis. According to the analysis of the 2000 U.S. information, on April 1, 2000, the population of the United States stood at 281,421,906.
What are truth values and truth functions?
As seen above, when discussing propositional calculus. A proposition is any declarative sentence that is either true, T, or false, F. Mathematicians refer to T or F as the truth value of the statement. The combinations of such statements are known as truth functions, with their true values determined from the overall true values of their contents. Truth functional analysis includes the following logical operators. Negation. The negation of a statement is false if the original statement is true, and true if the original statement is false. It refers to it is not the case that or simply not in natural language. Conjunction. The conjunction of two statements is true only if both are true and false in all other instances. It refers to and in natural language. Alteration. Alteration, or disjunction, of two statements is false only if both are false and true in all other instances. It refers to or, and either, or. In natural language, conditional. Conditional, or implication, is false only if the antecedent is true and the consequent is false, and is true in all other instances. It refers to if, then or implies in natural language. Biconditional. Biconditional, double implication or bi-implication, is true only if the two statements have the same value. Either true or false, it refers to if and only if. In natural language.
What are the 5 postulates of Euclid?
Euclid was also famous for his postulates, propositions, statements that are true without proof and deal with specific subject matter, such as the properties of geometric objects. For more information about postulates, see Foundations of Mathematics. Along with definitions, Euclid began his text elements with 5 postulates. These postulates are as follows, some of which may seem obvious to us now. But in Euclid's time they had yet to be formally recorded. It is possible to draw a straight line from any point to another point. It is possible to produce a finite straight line continuously in a straight line. It is possible to describe a circle with any center and radius. All right angles are equal to one another. Given any straight line and a point not on it, there exists one and only one straight line which passes through that point and never intersects the first line, no matter how far the lines are extended. Another way to say this is, one and only one line can be drawn through a point parallel to a given line. This is also called the parallel postulate. Mathematicians first believed this last postulate could be derived from the first 4. But they now consider it to be independent of the others. In fact, this postulate leads to Euclidean geometry, and eventually to many non-Euclidean geometries that are made possible by changing the assumption of this 5th postulate. Like many early attempts at explaining mathematics, not all these postulates tell the entire geometric story. there were still a large number of gaps, many of which were gradually filled in over time.
Where did the symbols for division originate?
The history behind the division symbols is long and complicated. The following lists how the major ones developed, closed parenthesis the arrangement 8, 24, meaning 24 divided by 8 in this case. Was used by Michael Stiefel, 1486 or 1487 to 1567, in Arithmetica Integra, 1544. The obelisk by 1659 Swiss mathematician Johann Heinrich Rahn. 1622 to 1676, introduced the division symbol, O, called an obelisk, in his book Touche Algebra. The symbol was a combination of colon and dash. This division symbol was used by many writers before Rahn as a minus sign. In 1668, when Rahn's book was translated into English with additions by English mathematician John Pell. 1610 to 1685, the division symbol was retained. Some say Pell greatly influenced Rahn to develop the symbol. But most historians agree that there is little evidence of such a connection. Another sign for division, the slash, was actually first used for fractions, such as 2/3 or 1/2. It can be extended into other, larger, or smaller numbers, such as 123/112 and 0.112/0.334. Little is known about its origins, but it is known that the symbol was sometimes used for subtraction, until it became standard practice for representing division.
What is an electronic calculator?
Most people nowadays are familiar with electronic calculators, small, battery-powered digital electronic devices that perform simple arithmetic operations and are limited to handling numerical data. Data are entered using a small keypad on the face of the calculator. The output, or result, is most commonly a single number on an LCD, liquid crystal display, or other display. It took a long time to go from the electronic motor-driven mechanical calculator to the electronic calculator. In 1961, the company Sumlock Comptometer of England introduced the Anita, a new inspiration to arithmetic, the first electronic calculator.